educational briefing around Type C Masterclass. Most importantly, providing Type C clarity to IT professionals. Look, thanks first of all for joining and sharing your time with us today. And ultimately, you know, you're going to find that this educational briefing is not a long, drawn-out sales pitch like we hear in a lot of these webinars. Targus is really taking the stance of being the best educator in the market. And most importantly, we are looking for areas where there could be some confusion in the marketplace. And let's face it, there is some confusion around this conversion that many of you are either have done, you're considering doing, or you know it's in the horizon and you're looking for answers. And we're fortunate to have one of the senior technicians, senior engineers with us, Kevin Quinn. I'll tell you a little bit about him to not only share his insights on what's happening in terms of trends in the market, some confusion in the market, even mistakes companies are making right now, so that you will not only learn from Kevin, but we're going to have open Q&A at the end of this 30-minute educational briefing. So make sure as you're looking at your meeting elements that there's an area where you can ask questions, and we will take live questions at the end of this 30 minutes past the hour. So let's get into the details of what we're about to cover and what you're going to go through together. First, of course, we're going to have an introduction and overview. We're going to talk in detail about the USB-C connector. We're going to talk about USB 1, 2, and 3, as well as 3.1 and 3.2. We're also going to really work to eliminate some of the confusion around power delivery and alternate modes, as well as audio and video as it relates to USB. We're going to talk about the Type-C cables, and we're going to look into the details of the considerations. And as mentioned, make sure that you're taking notes, or if you have a question during the course of this briefing, just type it in, and we've got a moderator that's going to ask the questions live when we're done. We are here to serve you at the highest levels. But let's face it, everybody, one of the biggest problems we're all facing is this confusion around USB-C and compatibility. The truth is this: we know that it can do so many things, but one of the things that Kevin is going to go deep on is making sure we realize that not all Type-C conversions are the same. So while we believe it can do so many things, we have to realize they can't necessarily do all things. So the purpose of this session is just really the baseline statements is this: not all USB-C or Type-C ports are the same. While USB-C enables data, power, and video over a single connection, it doesn't mean all those capabilities have been implemented on the host or the device. Next, even if the USB-C port receptacle is marked correctly, various hosts and devices aren't always completely compatible. And this is making many to call it USB Type-C for confusion. And in this session, we're going to compare the popular protocols being run around or on USB-C and describe why understanding the capabilities of USB Type-C connector is important when choosing both hosts and devices. A little bit about our leader today, Kevin Quinn. And I've had a chance to get to know this guy, and he is the real deal. If you haven't tracked him on LinkedIn, he's known on LinkedIn as the Doctor spelled D-O-C-K, if you get that. But a little bit about Kevin's background before I turn the screen over to him. He is the Senior Director of Applications Engineering at Targus Global. He graduated from Ohio Institute of Technology with a degree in electronic engineering technology. He has a master's degree in science in engineering management. He has over 30 years experience in electronics and information technology, including uninterruptible power systems, semiconductors, and RF. Also, he has in-depth experience working with servers and storage. He's also a design engineer, both ODM and OEM. And today, as I mentioned earlier, Kevin is the Senior Director of Applications Engineering around the world, also known as the Doctor. So grab your pens and paper, take great notes. We are recording this if you want to share it with other members of your team or other members of your peer group. Kevin, take it away, my friend.
Thank you very much, Gene. Let me start sharing my screen here. Get going. I want to make sure I share the correct screen. So everybody, thank you as we toss it over here. Thanks again for that rousing introduction. I appreciate it, Gene. Every time I hear it, I remember I should go ask my boss for a raise. You really make a lot of, thank you very much. Hey gang, again, as Gene said, thank you for joining us. For those of you on the live webinar today, we are going to do a Q&A session at the end because I am going to try to cover a lot of information, go a little bit deeper than I did in the last presentation to try to unconfuse you that may have questions. Any of you listening to this recorded session, get a hold of your Targus rep, and I'm going to tell everybody, check out targusblog.com. I put a lot of the little details and app notes trying to unconfuse Type-C and how to use some of the Targus products and some of the others out there with different hosts and devices and combinations of the Type-C port connection. So a little plug for my blog there, targusblog.com, or our blog, targusblog.com. Take a look at that. Feel free to follow it, and you'll get a little email anytime I post something that may interest you or not. Today, though, we're going to cover the four, and I'm going to really call it 4.5 or maybe 5 areas of confusion around Type-C if you include cables. We're going to talk about the USB Type-C connector, and that's the number one thing to remember. It is just a connector, and that means that connector can be used for several things. We'll talk about those things today a little bit more in depth than we did last time. The confusion around just USB and what that really means now that there's other specifications and we've changed the names of some of them. We'll certainly talk about USB power delivery. And if I were to rank these things and then the alternate modes, if I were to rank these things and how much confusion they cause, it's probably in order. 1 being not too much, 2 being a little bit more, and all the way to the alternate modes where probably the most confusion exists around Type-C. And then, like I said, if time permits, we'll say a little bit about cables that might be helpful to you guys. Alrighty, so there it is. There's the Type-C connector. If you understand this, you're done. No, I'm just kidding a little bit here. You'll notice that's the receptacle on the top. If I'm not politically correct, I call that the female, and the male below, or plug. Yes, receptacle and plug are the politically correct terms. So we use those throughout here for the most part. So, and I trip over the word receptacle because of my Ohio accent. So if that happens, please be patient with me. But if you notice, what's really nice about the Type-C connector is the plug can be turned upside down and still work the same into the receptacle. If you study this diagram and look at it and think about it, you could see that you could turn it either way and still make the proper connections for ground, for power, for data USB 2, and for all your high-speed lanes. And so we take advantage of that in the alternate modes and in just connecting with USB. That is to say, unlike the old Type A-B, where we always had problems, oh, sorry about that, like the old Type A, where we never even said Type A and Type B because we just knew it was USB, and that the host end was always Type A and the device end was always Type B. With Type-C, both the host and device end are Type-C, the same plug and same receptacles, so same port pair. And in the past, we would just say USB because that's the only thing that connector was designed for, the old AB days. But Type-C, we don't want to just call it USB because sometimes it doesn't even have USB. It almost always does, but sometimes it doesn't. And that's what we're going to go through today. Just to tell you what I'm going to tell you before I tell you, we're going to be going a little bit more into the connector. But just remember, USB-C is really just the name of the connector. And this frustrates a lot of people in the industry. And if I can switch to video mode, I'll show you what I mean. Without showing you a particular company or brand. Let me try here real quick. I'm going to start my video. And I think I have to stop sharing. Is that showing up for you guys? Costa or Gene, maybe you could tell me. At any rate, what you see right here is the system requirements. And this is a USB-C travel dock, all right? And the system requirements there show works with any computer with a USB Type-C or Thunderbolt 3 port. And that's just not true. This is an alternate mode docking station. And I'll explain what I mean by that here a little bit later. So let me figure out how to stop sharing my video and go back to presentation mode. So anyway, remember, USB-C is really just a connector, and a lot of people out there are still saying USB-C and not really saying what they mean it's doing, because the connector does enable USB 3.1 and 3.2 data. In fact, that's what it was invented for. It was invented for 3.1 At the time, we were throwing around the idea of USB 4 or something else, or 3.2 or something else. It ended up being named 3.1, and there's 2 generations of that, right? You have your Gen 1, the new name for super speed, or 3.0, and Gen 2, the faster 10 gigabit speed, now called Super Speed Plus. Excuse me. And just recently here in December of 2017, we developed a spec for 3.2, which is 20 gigabits per second. Try not to get confused. 3.1 Gen 1 versus 3.1 Gen 2 versus Gen 2, 3.1 Gen 2 versus 3.2. So these are very different things. There they are in summary, very different protocols. The good news is they are all backward compatible. All right. The other thing that gets confused a lot is people assume that this connector is USB 3.1, or they'll call it USB 3.1 connector. It's not the USB 3.1 connector. It's the USB Type-C connector. All right. It can have 3.1 data, and as I showed here, it can even be 3.2 or one of the other alternate modes or something like that. It can have power delivery. So it enables all of these things, but it doesn't necessarily have all of these things, and that's what I'm going to try to talk about going through this presentation. As I mentioned earlier, the alternate modes, probably the most confusing. The alternate modes being ways to do native digital audio video signal implementations. DisplayPort alternate mode is probably the most confusing because it can be implemented in 2, 3, or 4 lanes. Adaptive, high bit rate 2 or 3, fully featured, does it support multi-stream transporting, transport of the DisplayPort signal, and we'll talk about that. Thunderbolt, another very prevalent Type-C alternate mode, and it is an alternate mode, and Thunderbolt 3 runs on the Type-C connector. We're going to talk about that because these are the 2 biggest ones I see out there. We'll talk a little bit about MHL and HDMI alternate mode. Not too much. We're going to really stay probably with these 2. That's all we have time, and those are the 2 prevalent ones. But the thing to take away with the alternate modes, if you take away nothing else when it comes to alternate modes, is some are compatible, but not all modes are compatible. So there are some that are, some aren't. And I'll try to explain that as I go along here to help you out. You almost need a chart to do that separately in a whole different presentation. But I'll try to summarize that as we go through here. And as I said, I'm going to talk a lot about USB power delivery. That's important because without a power delivery contract, your alternate modes don't even work. So it's important to understand that point of things. And that's what I have down here where I say PD contract can get stuck, causing your data video to fail. We'll talk about the differences in PD 2.0 and the PD 3.0 spec, not to be confused with USB 2, USB 3, or Gen 1, Gen 2, or 3.1 or 3.2. This is the PD spec specifically, PD 2 and PD 3. Both of them provide up to 100 watts of power, a little bit differently, and we'll talk about those differences. The good news is, if you're PD 3, you're backward compatible to PD 2. Where the confusion comes in a lot of times with power delivery is not all sinks and sources are compatible. That is to say, things that need power may not be compatible with the sources that can give power. And we'll talk about what I mean there. Another thing that confuses people is USB power delivery pass-through and the ability to do variable on-the-fly changes to power and requirements for devices. So we're going to try and cover what amounts to several hundreds of specifications, probably 8 or 10 of them interacting with each other here in the next 30 minutes or so, and leave time for questions and answers. But again, can't go into all the details, would love to. If I can't get all your questions answered, check out targetsupply.com or get a hold of your Targus representative and get to me. We'll get you the answer. So first, a little just timeline of USB, because indeed we had USB 1, USB 2, USB 3. Now we have 3.1, 2 different generations, and 3.2. And they're all laid out and their speeds and what they do. USB, originally we didn't say low speed. We just called it USB when it was 1.0. But then when we came out with full speed and high speed, we had to differentiate the original, so we called it low speed. And then here in 2008, we came out with super speed. That's our 5 gig. That's the one we're most familiar with, most prevalent today, USB 3. Still see a lot of USB 2, but mostly USB 3. And there's still USB 1 devices. There's still mice out there, et cetera, and so forth that work across all of these. USB 3.1, Gen 2 goes to 10 gigabits per second, and that's called super speed. And then we renamed USB 3 to USB 3.1 Gen 1, not really shown on this chart, but that's the name for this. And then, like I said, recently we've just come out with the USB 3.2 or 20 gigabit per second USB specification. Not any devices or hosts or anything available that I've seen yet. I haven't even seen silicon vendors show that yet. My prediction is we're a couple, 3 years off for having to even think about or worry about it. We'll see. Technology does seem to move faster and faster, especially if you're a Kurzweil reader. Any rate, that's USB. Pop quiz. What's the difference between these two ports? And don't worry about it. There is no online poll. You don't have to go in and answer. This is a rhetorical pop quiz, if you will. But in answer, not a lot. Both of these are super speed, and you'll notice the Trident logo. So all I did was put one of them on a Type-C connector and one of them on a Type-A. These are downstream facing USB super speed ports that'll go up to 5 gigabits per second raw data rate. They also both have some power, although this one does not do the full power delivery up to 100 watts. It's really only 7.5 watts, which is the same as this. How do I know this one's 7.5 watts? Well, the industry standard for marking that is the sideways lightning bolt with an arrow or a zigzag, if you will, as opposed to the Thunderbolt one that points more in a vertical session. So this is a charging port on USB Type-A. We know and love this for charging our phones, pads, and so forth. This exact same thing implemented in the Type-C port is what you see on the left side. So no difference in these two ports effectively other than the form factor. And that's trying to stress with you that Type-C is just the connector. It's not what it's doing. And that's a lot of the confusion in the industry right there. There's too many people that say Type-C or USB-C, and you don't know if they mean this or something very different in the alternate modes and for power delivery. So speaking of power delivery, again, this is probably one of the biggest, maybe tied with alternate modes for what causes confusion. And that's because we have to think about power delivery different with USB Type-C, again, because you don't know what's a source, what's a sink every time. And even looking online at the OEM's host devices or Targus and its contemporaries downstream devices, you don't always know what's compatible. So basically, starting with USB Type-C power delivery is where the compatibility questions need to be answered. And what you want to look at is, first of all, make sure that your sink and source voltages match. That's to say, if you have a source voltage of 12 volts, but your device sinking or taking power needs 15, it's not going to work. You just don't have a way to do PD with that. So that's the first thing. You want to make sure those voltages match within a tolerance. And that is to say, there's some pretty standard voltages, 5, 9, 12, 15, and 20 out there. Nothing to keep any vendor from going at 10 or 13 or something weird like that. But whatever the case is, they must match. The power supplier must be able to supply enough current to the downstream device or the sink, I should say, not the downstream device, but the sink, the thing taking power. And we say current here in amps, but most of the time people talk in terms of power, which is the product of voltage and current or watts. But make sure you have enough current to supply. So that's something to remember. And watch your power budget. That's something I'll mention a little bit later too and talk about. And then you must be able to establish a power delivery contract. As simple as that sounds, you must be able to what we call PD. If you don't PD, your data and video not function, as I mentioned earlier, when you're in some of the alternate modes. So very important to determine to be able to PD. Even if you do PD though, your power may not function as you expect. And we see this a lot with power pass-through. And probably the best way to kind of show that is to talk about a host or peripheral being able to source or sink power, and that can change dynamically. And I'm going to show that through an example here. So what I'm showing here now in the graphic is right here, right now, the way this is connected, the PC is the source of power. Forget about data for the moment. We're just talking about power delivery. So the PC is connected to the monitor. It's giving the monitor power, and things are fine and everything's great. But now I come along and I plug my monitor in. So now that's the graphic supposed to show. I've plugged this monitor into the wall. Now that it's got more power than is available from the battery of the PC, it may renegotiate the contract between the two And now the monitor becomes the source of power for the PC. So we've switched around from what we were before. Notice the sink was the monitor. Now the PC is the sink. So we've changed that. We did that dynamically. Why did we do it? Because, well, out of the wall, this thing has enough to power itself and power the laptop. It makes sense to do it in this case. It may not. Again, you have to make sure the voltage is matched and you have enough current. But this can happen. So that is to say that the power source and the sink swap roles. And then, say, for instance, I go ahead and unplug this. Guess what's going to happen? It's going to renegotiate and go back to where the PC is now supplying power to the monitor. So that's something to remember, is think your power through once you've determined that the voltages and the currents match and have everything you need there in terms of power. Alrighty, so moving on. I promised you a little bit of a PD2 versus PD3, and this is to show you PD2. This is the original power delivery that came with USB Type-C on the Type-C connector. And you can see it went to 100 watts. You need a 5 amp cable to be able to do that. The big thing you'll notice about PD2 is we had these things called profiles, and you see them there along the lines. What did a profile mean? It meant if you were, for instance, I'll pick profile 3, that you had 5 volts all the way up to 2 amps available, and you had 12 volts all the way up to 3 amps available, okay? That's PD 2.0. You had specific profiles of voltage and current levels. Well, because not everybody wanted 3 amps or wanted something less than 3 amps, or maybe even a different voltage, but they wanted to stay within the envelopes down here, we came out with PD 3.0. And so PD 3.0, which is backwards compatible to 2.0, it deprecated the power profiles for these power rules. And I use the word deprecated because it comes right out of the spec. So power rules define the voltage and current ranges that are offered in the different columns now, all right? And again, if you go all the way up to the full 100 watts, you're gonna need a 5 amp cable. That's what the little note 1 is here, all right? So we changed from those specific levels of voltage and current to ranges of power, because you can change the current throughout, all right? And you see, especially at the highest voltage in each one of these, you can change your current to be some subset of what's available totally, all right? That's the biggest thing. The other thing is, remember though, it's backward compatible to 2.0. So for instance, if I have a power supply that's a 60 watt, up to 60 watt power supply, and I plug it into a PD 2.0 device of 60 watts, it'll work, right? So that works fine. Other considerations with power delivery, you'll run into this. The number one question I get asked, especially in the Apple world, is, I have an 87 watt MacBook. It says it's an 87 watt power supply. Will a 60 watt USB Type-C power supply be adequate? In fact, it is. The new MacBooks, and I say new, they're a couple years old now, the 87 watt ones, that is the 15-inch with 4 Thunderbolt ports, that once at 87 watts, will still PD at 60 watts. It'll charge a little bit slower. Quite honestly, you may not even notice the difference, because while this can charge a little faster, the way batteries charge doesn't always mean that you're going to be pulling the same amount of energy over time. So it may just be fine for your application. But the bottom line is here, an 87 watt MacBook with PD 3.0 in this range will still PD at 60 watts, right there on the low end of the range. Another question I get asked is, hey, I've seen, you said, Kevin, that the specification for power delivery ends at 100 watts, but I've seen devices from manufacturers that have just a single Type-C connection, and they're providing 130 watts or more, and they're allowed to do that. Again, the Type-C connector is just that, a connector. It can be used for power. It can be used in a proprietary way. It doesn't have to follow the spec. It can be used, in fact, the Type-C connector, you can have a host that's perfectly compliant with one area of the spec, and a device that's perfectly compliant with another area of the spec, and the two not work together at all. So that's one of the biggest parts of confusion of the Type-C spec, is you can be compliant with one area and I'm compliant with another, and we just don't work together. All right, so basically back to that over 130 watts, they're allowed to do that in a proprietary way. The nice thing about most of those vendors that do that, they still cover the lower wattages that are in the spec. In this case, if you're a 130 watt power supply, it probably still PDs 100 watt. All right, so keep that in mind. The dynamic power roles, I showed that through the example earlier. You got to always remember who's taking or sinking power and who's giving or sourcing power, and that may change dynamically. You can imagine a situation where over here, like I was showing here, the monitor is supplying power to the PC. Maybe something happens with this power, still plugged in, but maybe something happens with it and the PC takes over. So you got to kind of know the state of these machines and what's going on. And of course, if the battery gets too low in this PC, it may not even be able to power the monitor, sorry, if it wasn't plugged in. So that can change. So power roles can change dynamically and on the fly. So keep that in mind. And then there's always these little nuances to power delivery that have to do with how the CC lines are used on quick charging ports, et cetera, and so forth. And again, I cover those in the blog, a little bit too detailed for what we're doing today in this presentation. Power delivery pass-through can be confusing to a lot of people because basically you got to determine how the power delivery contract is established and how are you connecting that device. For instance, at Targus, we have a dock, and a lot of people have dongles that you can plug into a Type-C port that does provide, say, up to 15 watts. A Thunderbolt port, typical Thunderbolt port, may supply 15 watts. And so it'll power that dongle or dock. We call that bus powered, and that works just fine. And you can use that dongle or dock for its functionality using the bus power. Now, if you come up behind it, if it has power pass-through and you plug in, say, the power supply that came with your laptop, now it's going to use the power, it's going to change the power contract to use the power from that power supply instead of from the laptop. And in fact, may even charge the laptop. So you got to remember that with power pass-through and how things change. And by the way, while it's negotiating that new PD contract, you may use some of the functionality of the dock or dongle that you're using while it's doing that. So keep that in mind. That is to say, you need to understand which power delivery device was powered first, and then how the other side's powered. Always keep in mind your power budget. This comes up a lot with power pass-through devices. That is to say you have a power pass-through port that you have a power supply plugged in at 60 watts. Remember though, if you're power passing through a device, that device takes some power. And sometimes it could take as much as 10, 15 watts on its own. So you've plugged in a 60 watt power supply into a power pass-through port of a device that takes 15 watts. You're now down to only 45 watts going out the cable or available to the computer that you're trying to charge. And that thing may not do a power contract at 45 watts. So you got to keep in mind your whole power budget and everything in the chain taking some power and knowing what those numbers are. Usually it's in the specifications, not always. And I always tell people, even if it is in the specifications, try it, make sure it works in your environment. And then of course, cables. Some cables aren't rated to do, we talked about that earlier, the need for a 5 amp cable when you're doing 100 watt USB Type-C power. A 3 amp cable rated at 3 amps won't do it. And how do you know what it's rated at? Well, you got to look at the specs. If it isn't marked, and not too many cables are marked. So cables do come up into play with power alone, not just data. And we'll talk about their implications on the data side too in a moment. So that's all I was able to cover today with power delivery in the time allotted, but we're going to go on to alternate modes and maybe a little bit deeper dive than we did in the first presentation to kind of help you understand this. Those of you who were in the first presentation a couple of weeks ago, I talked about the alternate modes at this high level. I said earlier, from my perspective, it's a DisplayPort alternate mode world on the Type-C when you talk alternate modes. On the host side, you're seeing more and more Thunderbolt coming on, but primarily on the device side, it's a DP alternate mode world. And this is the mode I want to cover first because basically the DP alternate mode is the one that gets mislabeled the most. It gets called USB-C, it gets called Type-C, it gets called DisplayPort, and it gets called DisplayPort alternate mode, and it gets called DisplayPort DisplayPort multifunction DisplayPort alternate mode. So, and display, and just display. My English counterpart, Dr. Who's in the office today, so he just nodded that one to me. So this is the most confusing alternate mode. So we're going to cover that one and Thunderbolt because it comes along with that. Just to show you how the same Type-C connector is used for the different alternate modes. I put this chart in here. I'm not going to spend a whole lot of time on it, but you'll notice that the Thunderbolt's a little bit different from using it in a USB 3.1, whether it's Gen 1 or Gen 2 mode. You'll notice in a purely DisplayPort mode where you have all 4 lanes being used for display data, that is ML0 through ML3, and then you have DisplayPort multifunction, which is the most common for docking, for instance, in any dongle with USB. Why? Because, well, we need at least 2 of those lanes to do the USB super speed signaling, not super speed plus, but super speed. And then we leave 2 others for doing display port information. And so that makes this a 2-lane DisplayPort solution. And I'll explain what that means in the next chart. So basically, DisplayPort and multifunction DisplayPort. This is probably the most confusing alternate mode. And I'm going to try to provide, without saying why so much, but how, or even how, but why this is confusing. The biggest reason is an alternate mode or DisplayPort alternate mode is what it should be properly called port. One that people call USB-C, Type-C, and all kinds of things, but really should be called a DisplayPort alternate mode port. Can have 2, 3, or 4 lanes of DisplayPort high bit rate data in different high bit rates. I'll explain in a moment. So back on that connector, it can be in this mode where it has all 4 lanes for DisplayPort, or just 2 lanes, or even 3. I haven't seen too many implementations with 3 because usually they're doing USB or multifunction DisplayPort alternate mode. So 2, 3, or 4 lanes. Where that comes into play, say for instance, you have a host DisplayPort alternate mode port, usually labeled from Dell. Dell does a great job of labeling it. They'll usually label that a DP port, and it is. So that is to say, if you take that DP Type-C port, which is DisplayPort alternate mode in all 4 lanes, and you connect that directly to a monitor, you're going to get a beautiful DP 1.3 high bit rate 3 signal capable of doing 4K ultra high definition at 60 Hertz. And that's a wonderful thing. Where the confusion comes in a lot of times is, now if you take that same port and you connect it through a dock where we have to take away 2 of those video lanes to use for the USB hubbing and other functions in the dock, what happens is now you're at 2-lane DP 1.2 high bit rate 2 data, and you can get easily 2560 or 2 1080p displays. You can do 4K 30 pretty safely. And my Doctor Who counterpart's kind of blinking at me because he's been frustrated by, not always, because it isn't always, that depends on the host vendor. But for the most part, you can count on with 2 lanes getting a 4K 30, and it's theoretically possible for sure. The bit rate, the data rate does support it, and the cables support it. So a lot of confusion out of how you're using a DisplayPort host port. This next bullet here, multifunction docking ports, that's what I was explaining, those change. Another port of confusion with DisplayPort alternate mode is the support of multi-stream transport. How this shows up is, quite frankly, plain and simple. Apple does not support MST on the latest versions of OS X and in their MacBooks running it. They do support Thunderbolt with 2 separate discrete full 4-lane video streams, and I'll explain that in a moment, but they don't support MST. So when you're using Apple, think no MST. Most PCs do support MST. Not all of them, but most of them do. That is to say, you can take a single DisplayPort alternate mode port and get 2 external displays of 2 separate renderings. Again, at no more than 4K 30 total. So if it's 2 HDs, you can get 2 discrete separate renderings. If you use it on a MacBook, you're going to get 2 of the same rendering on those external displays because the MST support's just not in the Mac OS. The other nice thing about DisplayPort and multifunction DisplayPort or DisplayPort alternate mode is it is Thunderbolt host compatible. That is to say, but not the other way around. So that is to say, if you have a Thunderbolt host and you hook up a DisplayPort alternate mode device or dock, it'll work. But if you have a DisplayPort host and hook up a Thunderbolt dock, it won't work. Now that will change. There are implementations of the new Intel chipset for Thunderbolt called Titan Ridge. There are implementations that will change. And therein lies another bit of confusion, because now that you can connect a DisplayPort host to a theoretically Thunderbolt dock, it'll work in DisplayPort mode with the new Titan chipset on some designs. It doesn't mean that it still works on every Type-C port. So don't be confused by that. Don't be fooled by the marketing hype. It's a more compatible version of the Type-C implementation of Thunderbolt and DisplayPort, but it isn't universal yet. Most of the alternate mode docks out there, you'll see they're right around 60 watts. Why are they not 100 watts and so forth? Is most of the machines, when I say you're only getting two lanes of video anyway, 60 watts is plenty fine. So that'll work for most machines. There are some higher end Latitudes and some of the Z-Books, et cetera, and so forth that want a little bit more power. USB 2 is always there, and PD is available in alternate mode. Again, doesn't have to be implemented. Most of them do implement it to 60 watts, mostly PD 2.0 solutions out there. When it's in multifunction mode, it has the USB 3.1 Gen 1 or super speed data, and the other two high-speed lanes are used for the DisplayPort, as we talked about. Cable-wise, you can get away with a full-featured passive cable, which its relative cost to a regular old AB cable is just a little bit more, but it's certainly probably quite a bit less than most Thunderbolt cables you'll see out there. And when I talked about cables, if we get time, I'll go over that in a little bit more detail. So speaking of Thunderbolt, there it is. That's right there. That's the Intel, right out of the Intel marketing play deck. It says it's the USB-C that does it all. And this causes confusion because people read, oh, I get 4 lanes of PCIe Gen 3, 8 lanes of DP 1.2 HBR data, 3.1 Gen 2. I get all of this stuff, even 10 gig Ethernet. But if you do the math, you'll realize very quickly it can't do all of these at once. It's just not possible. So it has all these wonderful features, and this marketing slide looks like it does all of this at once, but it doesn't. So while it is the USB-C that does it all, and I am very pro Thunderbolt, especially for performance applications, I will tell you it isn't that it does it all at once. And so you have to dig into what your receptacle port or your host port is really supplying in Thunderbolt. Many of them have, like I said, 2 full 4 lanes of video data. Some of them just 1. Some of them support MST on the PC side. The Mac side doesn't. Some of them support power delivery, both as a sink and a source. Some of them just give you 15 watts of downstream power. So this port, while it can do all of these things, including power delivery of up to 100 watts, it isn't necessarily doing all of them all at once. So with Thunderbolt, you give up a couple things. Basically, while it's wonderful for video, that is to say you could have 2 discrete 4-lane DP 1.2 high bit rate 2 lanes of data. Remember, this is DP 1.2, not 1.3 that you had in the alternate mode, which is compatible and down to 1.2. It's 1.2 today. This is moving to 1.4 later, and we'll have to see how that's implemented when, especially, you have the compression of 1.4. But keep in mind, it is a lower DP that you have on Thunderbolt, but 2 full 4-lane discretes as a host most of the time. Not every host has it, but that's what it's capable of going up to. MST is optional. Like I said, it's the same as on the DP alt mode. That is to say, Apple doesn't support it. DisplayPort alternate mode and the PC guys do. It supports 2 monitors all the way up to a maximum 4K 60 24 bits per pixel color uncompressed. But that's what we say in the marketing stuff. But if you do the math, a single 4K 60 hertz 24 bit per pixel 4-lane stream is 22 gigabits a second. Just the data set alone is 17 gigabits a second. So just talking the data set alone, unencoded, no 8B, 10B, is 35 gigabits per second. So there's no way you can tell me you got 2 full 4K 60 hertz 24 bit per pixel streams at the same time as you have, let's say, 3.1 Gen 2. Because last time I looked, 35 gigabits plus 10 gigabits was 45 gigabits, and Thunderbolt goes to 40 gigabits. So keep in mind, a lot of confusion around Thunderbolt is just making sure that while it says it can do everything, you got to know what it is doing and how it's doing it. So keep that in mind. Also keep in mind that it is just 2 DP 1.2 lanes when used with a DP alt mode downstream device for the most part. Intel does like to say that as a downstream power provider, when it's not syncing or sourcing more, that it's a minimum of 15 watts. That's pretty prevalent in the industry. Most of the host ports I've seen, if they don't even go ahead and take 100 watts of power or something closer, they at least provide 15 watts for bus powered devices. However, I have found some that break the rules and are at 7.5, and I don't want to name names. I'm told not to say OEMs because we may pick a fight that we don't want because Targus is not as big. At any rate, 15 watts is typically your downstream power. It can be up to 100 watts of dual roll power. Keep that in mind. Voltage ranges typically on Thunderbolt ports 5, 9, 12, and 20. Don't see a lot of 15 out there. That's a longer story and it has to do with the Intel reference designs. From Targus, you're going to see we're supporting the full range, all the voltages that are popular out there. Data-wise, again, capable of 3.1 Gen 2, but if you're using all of this video and video takes precedence, you're probably not going to get anywhere near 10, probably closer to 3.1 Gen 1 or less speeds on your USB ports. And a port can be labeled Thunderbolt or Thunderbolt 3. And remember, especially if it's a downstream facing port, can be probably less than 20 gigabits per second of performance. Because you remember, and I've had customers, believe it or not, think that their first connection's 40 gig, they have 40 gig everywhere along the line. You don't. If you're using some of it somewhere with a device in the daisy chain, then the only thing left is the rest of it. So keep that in mind. Cable-wise, it does require a more active cable, a little bit more in cost, and a little bit less in length. And I'll talk about cables again well, right here. I've got time here, 11:42, good. Just to quickly go over cables, this chart is just really kind of show you a relative, starting with all the way back to our USB 2 cables. I showed in a Type-C form factor, again, because that's just a connector. So it can be USB 2, and I've even got a device look from about 10 feet from me that has a USB 2.0 receptacle in a Type-C form factor. So anyway, those cables, we can go pretty good distances. We can go, I never did do the timing analysis, but we can certainly go at least 2 meters plus in these, and they don't cost that much. The newer 3.1 Gen 1 or or 3.0 cables or super speed cables, still about the same cost, and they easily go 2 meters. Most of the implementations you're out there, you'll see are 2 meters. Still supporting USB. When you get to 3.1 Gen 2, you want to make sure you have a cable that does support those speeds. It's a little harder to go 2 meters, so you see most of those implemented at 1 meter, and they cost a little bit more too. This parity is coming along right now, so you should see all three of these being relatively low cost to other technologies, especially Thunderbolt. Thunderbolt, especially when you get up to 40 gigabits per second, you're going to be paying for that. And two ways. You're going to be paying for it in cost, and you're going to be paying for it in dollars, or in length, rather. You'll notice here I show 0.7 meters. That's kind of the leading edge or the current edge of technology. We are pushing to 1 meter right now. You will see on the Apple side a 0.8 meter Thunderbolt 40 gig cable. It is out there, but for the most part, the 0.7 is where they sit. And the lower speed cables out there around 0.5 meters at 20 gig are pretty safe. The important thing to take away though here is if you have a Thunderbolt connection, Thunderbolt to Thunderbolt, use a Thunderbolt cable. Look for this logo and be careful that it is just this logo, because I'm seeing knockoff cables that kind of look like this logo, but they're not. This is the logo you want, especially at 40 gig. Make sure you have it. These cables over here, while they're wonderful for especially this one for alt mode and these for regular old USB, and you sometimes get away with them on alt mode, you still want to use this for alt mode, you definitely got to use this for Thunderbolt. That is to say, these cables will give you some functionality in Thunderbolt, but certainly won't give you the 40 gig Thunderbolt capability. So keep in mind the cable connection is important. While they may all look alike at the connection, the port connection, they should be logoed differently. These are the logos you want to look for. That is to say, if you're using just USB for USB docking or dongles, make sure it has the super speed logo. If you need the faster for alternate mode or USB super speed plus, look for that little 10 And if you're using Thunderbolt, make sure, especially if you're using 40, that you have the little 3 there. So cables are important also. So in conclusion, in summary, and I'm just edging up on my time, I'm going to leave it for questions and answers, but the things you must know for compatibility: does it deliver or accept power, sink or source power, or both, and when? When does it change? So those are the things to remember. Remember, make sure you have your voltage levels matching, you've considered your power budget, and you have enough power for that power budget, and that they're protocol compatible. And a lot of times the data sheets aren't very clear on that. Like I said, there's still a lot of confusion on just what USB alternate mode or USB-C means. But you got to dig deep here, consult with your vendors, call us, we'll help you with that. Does it have audio video data, and what is supported? Is it USB 3.1 Gen 1 or Gen 2 that uses a compression algorithm for video from companies like DisplayLink, Silicon Motion, J5 Create, etc.? Or is it one of the alternate modes where it's native? If it's DP alternate mode, does it support MST? Is it Thunderbolt alternate mode? Which speed? Is it the 40 gig or 20 gig or something lower? Or is it some other mode, audio adapter mode, et cetera, or something proprietary? So be careful, making sure that the cable on your device is compatible with the cable connection on your host, the port connection. Is it the correct cable or adapter? We just covered that, so I won't go into the details, but make sure you have the modes and speeds and power level. And if it's required to be actively marked for your devices and host, that it is. So with all of that, I'm just a couple minutes, maybe a minute over my time frame here. I'm going to toss it back to Gene, but because I'm working for Targus, I got to give you this quick sell. Targus has solutions for Type A with power that can be converted to Type C, and we have Type C solutions that can be converted to Type A with power. So keep that in mind when selecting your devices, especially your docking stations. That's our area of expertise. So Gene, if you want to take it from here for any questions or concerns, I'd appreciate it.
Hey, Kevin, we did have a couple questions submitted prior to the briefing that you just did. And I know you answered some of these, but I want to make sure we acknowledge the question and you can answer them again. The first one comes from Vaughn, who asked, what are the differences between USB-C and Thunderbolt? Why would you choose one over the other?
Great question, Vaughn. I was trying to cover that in here, and I talk about that a lot on my blog, and the differences there. I do like Thunderbolt cable docking for your high-end applications. In other words, what you want to do. The big difference is speed. And when you said USB-C and Thunderbolt, I got to be careful there, because Thunderbolt, I understand you're saying either 20 gig and probably more often 40 gigabit Thunderbolt. When you say USB-C, I'm not sure, Vaughn, if you mean USB-C being DisplayPort alternate mode. Probably you are, or maybe you just mean USB. So let's talk about it and assume you mean DisplayPort alternate mode. Again, if it's DisplayPort alternate mode and you're just going to a display, you have all 4 lanes available. You can do a dual 4K 60, a dual 4K 30 display really easily, or a single 4K 60 in this case. If you go to Thunderbolt with a 40 gig Thunderbolt link, you can do twice that, because you have 2 times 4 lanes of video data. So Thunderbolt's a lot higher in speed than what people are calling USB-C, meaning DisplayPort alternate mode. And DisplayPort alternate mode is a little more functional than regular USB on Type-C. So I hope that kind of answers your question. Feel free to get a hold of your Targus rep, or check out targusblog.com. Get a hold of me, and I'll go over it with you in detail if I didn't answer it. Thanks, Vaughn.
Next question comes from David, and David asked, will the Targus dock work with a USB-C monitor?
Another great question, David, and I think we're hitting on the same thing that Vaughn was hitting on, a USB-C monitor. The first question I'm going to ask, but maybe I would assume that it's DisplayPort alternate mode, and that is to say, would a Targus dock work with it? Yes, is the answer. It depends on which Targus dock you want to use. The good news is, because it's DisplayPort alternate mode, I'm assuming downstream, that means our DisplayPort alternate mode docks and Thunderbolt docks will work with it, or anybody's host port that's DisplayPort alternate mode or Thunderbolt will work with it. Where it might not work is if you have a just regular old USB super speed or super speed plus on a Type C, or even just regular old high speed USB 2.0 on a Type C port, and you try to connect that DisplayPort alternate mode monitor, it won't work. So I put a little compatibility chart in the blog. It shows up under an article, I want to say, the best way to C or USB Type-C. So thanks for that question, David.
All right, two-part question from Cindy. And by the way, for all people that are listening right now and watching, if you have questions, please type them into the Q&A button and we'll answer them right here. But this is the last one I have as of this moment, and it's from Cindy. She asks, why aren't more Type-C peripherals available? And the second part to the question, Kevin, is, and why are the Type-C hubs so expensive?
Cindy, the first question, Type-C, and once again, what David and Vaughn were asking, we're still saying Type-C and the industry's got you trained well. Unfortunately, I don't know what you mean by that. Again, Type-C is just the name of the connector. You have to understand what it's running on. Now, assuming that you're fooled by the industry, the Intels and so forth the world, meaning Type-C, meaning alternate mode, that whole compatibility is what I was trying to show here today. And the second part of your question, why is it so expensive? Alternate mode, actually, relative to Thunderbolt, is quite a bit less expensive today out there, but it is more expensive than regular old USB. So USB hubs and switches have been around for forever, and now that they're coming out in Type-C connectors on them, they're still inexpensive relative to alternate mode, where you're actually switching DisplayPort data, DisplayPort alternate mode, or one of the other alternate modes, and those switches aren't made in the volumes that USB hubs are. And then when you get to Thunderbolt, of course, that's a proprietary technology, only one silicon vendor, that's Intel. And while it's much higher in speed, much more capable, that comes at a cost and price. So that's why that costs quite a bit more. I hope that answers your question, Cindy. Did I miss something there, Gene?
No, but I do have one burning question, and this is what we asked when we were offline in preparation for this briefing. What's the biggest question you get? Now, Kevin, I know you're on with clients and the other engineers within Targus. You're on your forums with, industry engineers. What's the big crux of the matter? Where do you see the most confusion around this subject?
That's a great question, Gene, and it's just what Vaughn, David, and Cindy were asking me. That is, they said, why doesn't USB-C this? What is USB-C that? USB-C is just the name of the connector. It is not what it's doing. And so I can't answer compatibility questions. I can't answer, will this work with that, without knowing what that connector has on it. And so what's really frustrating right now is some big name vendors are making it more and more confusing by just going out there and saying USB-C when they mean DisplayPort alternate mode, or maybe they even mean just USB. The good news is when they mean Thunderbolt, they'll say Thunderbolt. But after that, when they say USB-C, you really don't know what anybody's talking about for sure. You can assume it's alternate mode, but doing that, then you got to go into all the questions that alternate mode comes along with it. Which alternate mode? If it's DisplayPort alternate mode, like I said, it could be 2, 3, or 4 lanes. So you got to figure that out. And then the whole power delivery thing probably has some power delivery. Is it just the normal 15 watts downstream, or is it all the way up to 100 watts upstream facing or sourcing? So too many questions around the whole Type-C. And by the way, it gets to be even more of a mouthful with phones and tablets because you have USB-C that's running quick charge and other proprietary technologies, because again, it's just the name of the connector. And so I get asked questions, people say Type-C or USB-C, and I don't know what they mean. I have to ask them more, and that frustrates them because we were used to just saying USB, and that meant USB. That's not true in the Type-C era. You have to know what that Type-C port connection is doing, both receptacle and plug. Long-winded answer to a question. I don't know if that helped, Gene. Did it?
It did, and Cindy just came back with another question. So thank you, Cindy, for actively participating. So she says, now I've got to read this the right way. I am doing, it looks like a sysadmin in a primarily MacBook world for a few PCs. I realized and understand the difference between the USB-C connector and Thunderbolt 3, although your talk will help me communicate the difference to my very confused, relatively non-technical users. Hey, Cindy, I'm one of those very confused, non-technical users. So, Kevin, did that question make sense? I am doing a sysadmin.
Yeah, it sounded like she's saying thank you, and thank you, Cindy. You're welcome. I hope it did help start to unconfuse things. The toughest part about it is USB was pretty simple to understand, the old AB, because again, it just worked. And the host side was always type A. That's why we didn't even say type A. And the device side was always type B, albeit sometimes micro B, etc. But we didn't say type B. And the only thing running on that connection was USB. Sometimes 2.0, sometimes 3.0, and sometimes lower, but it was always just USB. Now with alternate modes, alternate to running USB, there's a lot of confusion in a lot of those alternate modes. And again, because there's several specifications involved here, and you can be compliant with one area of those specifications, and something else is not compliant, or something else is compliant with the other area of the specifications, you still might not be compatible, not even work together, even though you're both compliant with the specification. And that's very different from what our USB AB area is. You can blame the USB special interest group. You could throw your hands up in the air, you could stomp up and down, but unfortunately that's the world we're living in now, because they made a connector that can do lots of things, and it does all of them well, but it doesn't do all of them at the same time well.
Okay, and it says that Matthew Walker has a question from Keith Weldon, who's a Targus representative. And Keith, do you want to type it in? Do you want us to unmute Matthew? What's the best way to do this?
I think he should make it the benefit of everybody on the call. So if he could type it in, that'd be great.
Okay.
Otherwise, since he's a Targus representative, he knows where to find me.
Okay. Well, while we're waiting for that question, we still got plenty of people on. So, Kevin, I mean, you're in this world and you're seeing the roadmaps and the forecast. What do you see happening 2 years from now?
The good news is, like any other technology, you know, we're not on the bleeding edge anymore. We still are on the leading edge. In the leading edge time frame, things aren't compatible, don't work. I think we'll solve a lot of these issues that I brought up here, especially around the power ones. I'm hoping, and maybe I'm a little bit of an optimist, so that I'll bring a little bit more of not having to worry about compatibility so much. Maybe we'll find in the end of the day, if you're an Intel person, you'll say at the end of the day, it's all going to be a Thunderbolt world, right? My cohort's grinning at me right now. The one thing, I'm pretty sure it's not going to be just USB. Well, I don't know, some of the alternate modes go the way of the dodo. There's a chance of that in those next couple of 3 years. So we might not be talking about DisplayPort alternate mode in the long term, albeit because Thunderbolt's there, and Thunderbolt's a lot more compatible and ubiquitous and cheaper and still not universal, but more compatible. So that's my optimist part. My pessimist part of me is, again, Type-C is just a connector. There's nothing to keep anybody from using it for anything they want in this industry. And so, I don't know, name your PC vendor. He may come out and say, I'm going to do things at 13.23 volts. And that's certainly non-standard. It'd be silly. That's a whole long story in itself. But they can do that. Or I can use a totally different protocol for the ones we talked about. There's nothing that keeps you from using it as just a connection between two things, even if it's just a mechanical one. So keep that in mind. I don't think that's going to happen. The industry would be foolish to do that. But at the same time, there's still a lot of foolishness going on by saying just USB-C and not finishing the sentence. Do you mean USB-C DisplayPort alternate mode? Do you mean USB-C multifunction DisplayPort? Do you mean USB-C 3.1 Gen 1? So that's that. The optimist in me is things will get better before they get worse. Plus, we'll all get a little bit smarter, a little bit more educated. So in a couple, 3 years, maybe our questions will be different. The bottom line is always consider your application. What are you trying to do? And that's the best way to pick your USB things.
Hey, Kevin, we still got some very smart questions from very smart people. One more from Cindy is one of the problems she's had is that she can't find a good dock for her MacBook users. And she says the various dongles don't have enough power on the bus to run 2 monitors and a network dongle. The one sold by Apple is rated 2.5 stars on Amazon. And do you have any recommendations for a good, reliable Thunderbolt 3 dock?
Quite frankly, Cindy, I'm at Targus, so I'm going to tell you the Targus Dock 220. But truth in advertising, any Thunderbolt 3 dock for a MacBook should work pretty good. The nice thing to look for is the Targus one, for instance, is Intel certified for both PC and MacBooks. So we'll look for one that's certified for MacBooks in your case. Targus-wise would be the Dock 220, but truthfully, any good reputable supplier with that Intel certification for their Thunderbolt 3 dock is probably fine. It depends on what you want for I/O and outputs. Get a hold of your Targus rep, get to me, and I'll help you narrow it down.
Yeah, but Kevin, being an observer is, you know, there's so much demand on the Targus docks right now, and there has been for several months, that, you know, it's hard to make as many docks as you're selling, which is a really good problem to have if you run a business. So what is it about the Targus docks that are causing so much demand? I mean, you say you can get them anywhere. Well, I also know I can get a phone anywhere, but I know the phone that I use in my book is the very best phone. I can get a cheap one or I can get a great one. And because I use it to run my business, I choose to get a great one and spend the money. So what makes the Targus dock different? And this is not a sales pitch. I just want to know.
Well, sure. Really, it comes down to, I think, that Targus is the industry experts when it comes to docking, for sure. And our support structure, you heard me mention Doctor Who in Europe. I go by the doctor. We have Dr. Oz in Australia and doctors around the world. We kind of play on that a little bit with the geographies. But, you know, we're focused on docking, and we're agnostic to the host device. So I will say, if you're a Dell house, you're only going to be buying Dells. Buy the Dell solution. Same with HP, same with Lenovo, same with Apple. Apple doesn't have a solution, but try to stay in your vendor. But we know that's very few people anymore. At least there's a few MacBooks in any decent sized enterprise. And a lot of times people are buying HPs or Dells or Lenovo's. Why? Because quite frankly, the guts of them are all Intel, and they're very commoditized nowadays. And I hate, if there's anybody from those companies on there, sorry to say that, but your PC is a PC is a PC. And even your Apple is not very different from your PC if you look at it at the core. So it makes those things more commodity. And it's more important to find the I/O, the things you need to do with that thing, and figure out which one you buy. The reason Targus is good at that is we're agnostic. We don't care if you're Lenovo. We don't care if you're Dell, if you're HP, if you're Apple, if you're a Chromebook, if you're a Android device, if you're a Linux box. We're going to sell you the same piece of hardware that works on all of them. And we're going to price it at a reasonably good price and supply it and back it up with the support and a 3-year warranty, all of those things. So I think that's what makes Targus a little bit better. Again, if you're Dell and just buying Dell, stay with Dell. HP, same thing. But if you want a universal or a ultra compatible or certainly validated across all those OSs and platforms, go with Targus.
Okay, one more just came in from Roy. Are DisplayLink docking stations capable of outputting 4K at 60 hertz over USB 3.0 with a USB-C adapter? Is this capability based on PD or other factors?
Roy, the answer is yes. A single 4K 60 certainly at 24 bits per pixel. In fact, dual 4K 60 at 24 bits per pixel. That being over USB 3 super speed with an adapter. That being said, make sure it's a legitimate adapter. I'm seeing lots of dodgy, as we use in the industry word, for adapters. Make sure you have a good one. Use the Targus one, quite frankly. And that's true for all the PCs. I'm seeing that on Linux. There's not that, well, no, Chrome works. There's not that support in Android, of course. And right now, Mac OS, there's an issue. I just got off the phone with the DisplayLink guys about that about a couple hours ago, and they gave me hope, but no dates or any more information that they would share or that I could share or pass along. So yes, the answer is, at the end of the day, Roy, dual 4K 60, but that is compressed video over USB. So if you're watching a video or using it for a CAD CAM application where you need no latency or super low latency, probably you're going to want to go to Thunderbolt. If you have a Thunderbolt machine. It's the same old thing. Try not to do a race car application using a passenger car kind of thing. But get a hold of your Targus rep, and I'll help narrow that down for you. In answer, Roy, bottom line is dual 4K 60 over USB super speed using compression technology from DisplayLink and others does work.
Kevin, before we wrap up, I have to tell you, I feel smarter just listening to you speak. So thanks for the, the educational lift. And, you know, that for everybody that's still remaining, we've got over 30, or there's plenty of people that are on this webinar. I just want to say thanks for your time and attention. And obviously, if you're looking for answers, reach out to whoever you're dealing with that ultimately deals with Targus, Kevin, as well as others within the you know, really the front of the edge experts in this marketplace. We're available to help you. And that's really the position that this company takes in the industry. Is, you know, it's not just about trying to sell something, but, you know, if we do a great job of teaching, educating, and making sure that you get the outcome that is your ultimate desire, then that's how this company continues to win long term. So thank you again. And I think all of you will get a recording of this. Feel free to share it. We're going to be having more educational briefings just like this one on a monthly basis. And that way, as you sign up, you know you're going to come in and you're going to get the goods, which is really, in a age where we're drowning in information, yet we're all starving for wisdom. That's the ultimate outcome of what these are. So thank you for your time and attention. Kevin, as always, it's a pleasure to interact and work with you and hear what's going on in this world where there's so many options. It can be confusing. So hopefully you've made other people's day brighter. You certainly did for me.
Thank you, Gene, and thank you everyone for coming.
Bye.
Bye-bye.